Let's take a look at some circle theorems. We'll do this by first understanding what the chord of a circle is. We're also going to take a look at some circle theorems, and we're going to try to apply them. The chord of a circle is a straight line segment whose endpoints both lie on the circle. It lies on the circumference of the circle or on the boundary of the circle. Now let's start with our theorems. The theorem states that the angle at the center is twice the angle at the circumference. So if you look at this angle CAB is going to be 2 times the angle CDB. Now let's look at theorem number 2. The angle in a semicircle is 90 degrees. It's an extension of the first theorem that says that the angle formed at the center is going to be twice the angle formed at the circumference. You can see that this angle right here, CED, is an extension from CAD. A is at the center, so that's 180 degrees because it's a straight line. And then when you extend a line from those 2 points on the circumference to another point on the circumference, you'll see that you also have 180 divided by 2, which is a right angle. Theorem number 3. Angles in the same segment are equal. So look at that right here. This is angle alpha, denoted by alpha, denoted by alpha. They are formed in the same segment, so they're going to be equal. Theorem number 4. Opposite angles in a cyclic quadrilateral add up to 180 degrees. So angle E and angle D add up to 180 degrees. They are supplementary angles. Angle C and angle F also add up to 180 degrees. They are also supplementary. Theorem number 5. The length of the two tangents from a point to a circle are equal. So that's all it's saying, is that from D to B, so here it's saying that DB is equal to DC. And these are going to form 2 right triangles. Now, theorem number 6. The angle between a tangent and the radius of a circle is 90 degrees. So this is going to be 90 degrees here. This is going to be 90 degrees here as well. So you can say that there are 2 right triangles that are equal. Because how do we know that they're equal? Because theorem 5 states that DB and DC are equal, and BA and AC are the radius, so they are also equal. So these are 2 equal triangles. So theorem 7 states that the perpendicular from the center, the perpendicular A represents the center of the circle. The perpendicular from the center bisects the chord. So this is DAC is that perpendicular, and EGF is our chord. So they form 90 degrees at the point of intersection. Now let's try to apply these rules, these theorems that we have learned. So here we have the angle. This is theorem number 1. It says that the angle at the center is twice the angle at the circumference. So 144 is supposed to be twice the angle at the circumference. So we divide this by 2, divide this by 2. So the missing angle is 72 degrees. So here in this diagram, it's the angle at the center, so the angle at the center must be twice the angle at the circumference, which is 2 times 63 degrees, which is going to give us 126 degrees. So here in this diagram, we see the angles formed with the angles formed in the same segment are equal when they're formed with the circumference of they're formed at the circumference of the circle. So that alpha is going to be equal to 42 degrees. So in a cyclic, or some will call it a cyclic quadrilateral, opposite angles are supplementary. So that means that C plus F must be equal to 180 degrees, and E plus D must be equal to 180 degrees. So C is 65 degrees plus Y equal to 180 degrees. Let's subtract 65 degrees from both sides. So Y equal to 115 degrees. Now in this case, E is 98 degrees plus X equal to 180 degrees. So we subtract 98 degrees from both sides. So X is equal to 82 degrees. And finally, we have this situation here where the angle formed with the tangent at the circumference is 90 degrees. So what we have here is we're trying to find out the length of BD. So we have a right triangle here. So let's try to apply Pythagorean Theorem. So which tells me that AB squared plus X squared equal to AD squared. So AB squared is 5 squared plus X squared equal to 13 squared. So X squared is equal to 13 squared minus 5 squared. Let's apply our difference of two squares. It's going to give me 13 plus 5, 13 minus 5. This is going to give us 18 times 8, which is 144. So X squared is 144. So we want to find the value of X. So we're going to find the square root of both sides. So X equal to 12. So let me just review this quickly with you. If you're confused about this method that I'm using here, go ahead and you can also say 25 plus, this is another way of doing this right here, 25 plus X squared equal to 169. We can subtract 25 from both sides. So X squared is equal to 144. It's just a different approach to get there. So these are the main circle theorems that would be covered in most standardized tests at this level.